screen share. And yes.
I think it's like the next slide. I mean, next to this.
Okay. This one?
Yes, sir, this slide. Yes, sir. Sir, could you please elaborate on the last 2 points? I mean, the case where the sender commits to speak honestly and the case where R could commit to let S take the decision. I mean, I couldn't understand how.
Yes, I'll talk about it today. It's going to be very much a part of today's discussion. Okay. I'll elaborate on these points and more in today's lecture. Any other questions? Everybody clear about the calculations, the concepts?
Yes, sir.
Okay, so let me start the set of issues I want to talk about today. Okay, so the theme of today's lecture is going to be rights as self-interested gifts. You know, in organizational life, in political life, we often see rights being granted to certain sets of people. You can go back in history, you know, there was in the medieval period or earlier, we had monarchies, right? People couldn't choose their leaders, and then starting with the Magna Carta in England, gradually voting rights emerged. Initially, it was restricted to small groups of people, the nobility and so on, but then gradually it expanded. It took us to arrive at the 20th century before it was expanded to women and so on. So today in many, many countries, we have universal suffrage. So that's one example of people getting new rights over time, the right to elect their leaders, their governments, and so on. You know, there are other kinds of rights you could think about. For example, the Right to Information Act, RTI in India, that we are quite familiar with. It wasn't there always, right? It was passed about a decade back, a little more than a decade back, which gives citizens to ask for all kinds of information from government, yes, how a decision was made, who participated, etc., etc. So it increased transparency in governance. Citizens, by law, have the right to seek certain kinds of information. The opposite of the RTI Act is things like the Official Secrets Act, which ring fences certain kinds of information, for example, related to security or defense. It ring fences it from the citizens. It says that, you know, these highly sensitive decision-making process on sensitive issues will not be accessible to anybody. So that's the reverse example of a restriction of rights, the Official Secrets Act. So broadly speaking, in today's lecture, we'll try to think about the consequences of these kinds of rights. What is the impact on various interested parties? And if you look at the title, rights as self-interested gifts, right? Anytime a right is granted, for example, when Europe started moving away from monarchy to a parliamentary system and some form of democracy, it is the monarch, the king, who transferred rights to citizens. So the monarch, when something like the Magna Carta was passed, the monarch reduced his own power and empowered ordinary citizens and you know, empowered others who didn't have those rights before. So it was a transfer of rights. And there's the new rights, the new democratic rights were granted by one party, one player, the monarch namely, and it was received by citizens. So the general theme here is going to be that there are situations where, of course, the recipient of new rights would, it's no surprise if they're better off in their process, if the welfare goes up. But the more subtle aspect of what we're going to talk about is that there are situations we can think of where even the party who gives out the rights to others reduces his own power and increases the power of others. Even that party can be better off in the process. Okay, so transfer of power can be a Pareto improvement, including the player who gives up power of some kind. Right. So that's the more subtle, the more perhaps surprising aspect of this, and that's what I'm going to focus on. Now, let's think more specifically about the cheap talk kind of game that we are studying. Okay, it's a very stark model. Some decision has to be taken. There are two players, the sender and the receiver. Both are interested in the decision and the outcome. To some extent, their interests coincide. For example, when theta is higher, both wants to take higher actions. So that's a common interest aspect of the game, but their interests are also to some degree in conflict because of that preference parameter B that we talked about. For any given state of the world, they don't entirely agree about what action ought to be taken. Now, in that simple model that we are studying, the Crawford-Sobel model, there are two important aspects of the game. One is information. Who has information about the state of the world? Who is well informed about the circumstances on the ground that affect utility or payoffs? Information is vested in one player, the sender, whereas authority, the power to take the decision, to choose the action, is vested in the other player, the receiver. The receiver is uninformed but has power, whereas the sender has information but no power, right? So there's this cleavage between information and authority in the game that we're talking about. And the game may be relevant to organizations, to a nation, or what have you, to government, the prime minister and advisor example, and so on. Now, the second bullet point is put a little more dramatically, somewhat inaccurately, but it's an exaggeration, but there's an element of truth to it, which is that power is maybe not useless, but its use diminishes considerably in the absence of information. If I can take decisions, but I'm not very well informed, then that power is not terribly useful to me. Similarly, if I have information but do not have decision-making power, then that information, the value of that information is lessened considerably. Now, so there are, to start with, we can think of two kinds of transfer of power, or one is power of decision-making. So you can imagine in some situations where the receiver, the decision maker, hands over the keys, so to speak, to the other player, the sender. Basically says that I am surrendering my decision-making power to you. So you have full freedom to take any action, to choose any action you wish. So go ahead, right? That is what we can call delegation. Yes. Another kind of transfer of power, whatever you want to call it, is where the sender gives up the keys to the information vault, so to speak, right? The sender says, okay, from whatever source I'm getting the information, I won't build a wall around it. I'll tear down the wall and I'll give you access to that information. He says it to the receiver, right? To start with, in the model that we are studying, especially in the uniform quadratic model that we are studying, we will show that both of these kinds of transfers are actually lead to Pareto improvements in general, or in many circumstances, many situations. And this is using the criterion of ex-ante welfare, which is perhaps the natural criterion to use. You can think of these games as being played not just once, but repeatedly. Sometimes theta is high, sometimes theta is low, sometimes theta is somewhere in the middle. So the relevant criterion there is, on average, how do the players do? How high is their welfare on average? If the game is played many times, then that is the criterion perhaps that they will use. Okay, so the main point is going to be that that both of these kinds of transfers, either the decision maker delegating the decision to the informed party, the sender, or the sender somehow opening up the vault of information. Let's call that a commitment to transparency. Both of these are welfare improving for both parties. And both of these can be thought of as conferring rights to the other party, right? Either decision-making rights or information-seeking rights. So the rights here are viewed as pragmatic instruments, not moral imperatives. Okay, so again, going back to the example of spread of democracy, was it a good thing? One view we can take is an axiomatic view that regardless of what the consequences are, a system where everybody has power, everybody can cast a vote to decide what collective actions ought to be. That respects the dignity of individuals, and it's important for its own sake. Here, the argument that we are talking about is not axiomatic. We are not saying that democracy necessarily is a good thing as an assumption. We are saying that if you care only about the outcomes, then certain kinds of power distribution in organizations can be a good thing. It can just lead to high welfare in pragmatic terms. As I said, the kind of rights transfers here will further the interests of not only the recipients of those rights, but also the ones who are giving away those rights. And if all parties are wise and forward-looking, and they can foresee, what the outcomes are going to be if rights are distributed in one way rather than another. If there's such wisdom and foresight among these players, then we can imagine these rights distributions, this conferring of rights, as something achievable without conflict, without a revolution, without a storming of the Bastille. Okay, so these are points to keep in mind as we go along. Okay, so first let's talk about delegation. So as I said, delegation means that the receiver R relinquishes his authority to make the decision. He hands it over to the sender, and the sender is given the right to choose the action. What is important is that this has to be a genuine commitment. Yes, it can't be that later the receiver can take back this right. Okay, then the whole thing breaks down. So there has to be a commitment mechanism, as we say. Where will the commitment, later the receiver may want to change the action the sender is about to choose, but there has to be no way for the receiver to do so, to take back the rights that he has given. Once the rights are given, it has to be genuinely out of the receiver's control. Now, whether such commitment is possible and in practical terms, how exactly such commitment comes about, that's not something that we'll look into. Yeah, you can think of, for example, a law being passed. The receiver either signs a contract with the sender or passes a law which is binding on him. which says that the sender can take any decision he wishes. The reason we need a commitment is that there is a tension between the ex post and the ex ante incentives of the receiver. Ex ante, the receiver is better off handing over this decision-making right to the other player. But ex post, after he learns new information, in particular, after he learns what action the sender is planning to choose, at that point, the receiver, if possible, would like to take back those rights that he gave away and change that action that the sender is choosing. So there has to be some commitment mechanism. In game theory, I presume when you talked about sub-game perfect equilibrium, you talked about commitment mechanisms, right? One very popular example is that of Fernando Cortés, who was a Spanish general. He was in command of the Spanish Armada when they were in South America fighting, the indigenous population, the Incas. And before a certain battle, the Spanish army was much smaller. They had better technology, but they were in numerical strength. They were much smaller than the Inca army. And on the eve of a certain battle, the story goes, I don't know whether it's historically accurate or not, but the story goes that Cortés burnt his ships that were anchored in the harbor, right? He very visibly, in a way that is visible to the Incas, he burned down all his ships. Now that seems stupid and self-destructive, yes. That means that he shut down the option for his army to run away if the battle was not going their way and they were taking heavy losses. But there was a strategic cunning in doing so. Basically, it made his army fight till the death, right? It committed his army to fight till the last man, because they didn't have the option to run away. And the Incas knew that because the burning of the ships was visible to them. And so that made the Incas more defensive. And if the battle was not going their way, they had a stronger incentive to surrender, to run away. So that's used as a classical example of a commitment mechanism, literally physically burning the ships and removing the option to exit from the battlefield, right? So something analogous has to happen here. The receiver has to have some way of committing to this handover of decision-making power. Okay, now suppose such a commitment mechanism exists somehow, right? We'll not get into the specifics of that. Suppose it's there in the environment. Then the question is, will the receiver want to actually exercise that commitment? Is he better off delegating than retaining the power to choose actions in his own hands? Now, if you think about it, if you step back from that question and think about it broadly, there's a trade-off involved in that decision, whether to delegate or not. What is the trade-off? If the receiver delegates, then the decision is more informed. Then if theta changes even a little bit, the sender who has been given the power can respond to that and revise the action appropriately, right? So the action can be finely tuned or customized to the conditions on the ground, namely what theta is. So there's more informed decision-making, and that's a good thing, even from the receiver's perspective. So that's the plus side of delegation. What is the downside? What is the negative side? The negative side is that the action choice in response to any information is going to be according to the sender's preference, not the receiver's preference. We can call that distortion. Since if we assume B to be positive, the bias factor, that means that on average, the action chosen after delegation will be higher than what the receiver would have liked. Okay, so it's a trade-off between more informed decisions and more distorted decisions as far as the receiver is concerned. And the receiver has to make a decision which of these two factors is stronger and dominates the other. As the bias becomes smaller, the cost of delegation becomes smaller. Remember, when B is small, even through cheap talk, you can have partitional equilibrium with many, many intervals. So yes, information gets coarsened, but it's not coarsened that much. Cheap talk becomes more informative. The cost of not delegating is smaller, but the cost of delegation is also smaller. When B is small, the distortion will also be small. It won't be that big. So it's non-trivial how the comparison works out, even when biases are low. Okay, let me further illustrate what I'm talking about here. So for the receiver's angle, whether to delegate or not, okay, that basically amounts to saying, well, should I play the cheap talk game, or should I just allow the sender to take the decision? If they play the cheap talk game, this picture shows the mapping between the state of the world and the action chosen. Okay, remember, all these equilibria that arises in the cheap talk game are of the partitional form. Yes. So just for the sake of illustration, we'll look at a 3-interval equilibrium. Suppose that's the most informative equilibrium. Now, first of all, the diagonal is very salient. If the receiver somehow also had the information in his pocket, somehow, then he will always choose an action equal to the state of the world. So that means the action state correspondence would have been along the diagonal, right? So the diagonal is like a benchmark. Ideally, the receiver wants to be on the diagonal as far as possible, or as close to the diagonal as possible. Now, if he's playing the cheap talk game, he doesn't have information about the exact state of the world. So, you know, the cheap talk gives rise to this partitional equilibrium. 3 messages are sent out, M1, M2, M3. M1 is sent over this first interval. What is the action that will be chosen when the message M1 is heard? It's the midpoint of this first interval, right? So that's the red, flat red line. Similarly, in the second interval, a different message is sent. The action chosen is the midpoint of that interval. So in that entire range of theta, the corresponding action is represented by this flat line. So you have a step function like this, okay? And obviously the red line is often away from the 45-degree line in most cases, and sometimes far away from the 45-degree line towards the endpoints of the intervals. Now, what if delegation takes place? What if sender is empowered to take the decision? Then the correspondence between the action chosen and the state of the world is represented by the blue line. So the sender, remember, will always choose theta plus b. Okay, so the action he chooses when he gets the power is going to be vertically b distant away from the diagonal. Yes. So now if you take a look at this picture, you can see that ex post, right, which is to say for a particular value of theta that gets realized, we cannot rank these two regimes in terms of receiver's welfare. For example, you know, at this cutoff point or close to this cutoff point, the red line is further from the 45-degree line than the blue line. So for these values of theta, delegation actually works better. But if you look at, for example, you know, at this point where the red line intersects the 45-degree line, if theta just happens to take that value, then the action is exactly what the receiver would have wanted for that value. But under delegation, the blue line is further away. So I can choose values of theta where cheap talk works out better than delegation for the receiver. I can choose other values of theta where it's the other way around. Okay, so ex post welfare wise, we cannot rank these two regimes. But what happens is And here I'm going back to I'll try to answer the question that was asked at the beginning of class today. Let's go back to that last posted video. Okay, we calculated receiver's welfare in that ex ante welfare. And I won't go through all the details. Essentially, the first step of the calculation is, suppose the receiver learns that theta belongs to some interval of length x. Well, he'll choose the midpoint of that interval. That's the best he can do in terms of action. And then his expected disutility, I'm ignoring the negative side, right? So this calculation is in terms of disutility rather than utility. It can be calculated to be 1/12 x squared. Obviously, if x is smaller, this is closer to 0. 0 is the ideal. And if x is bigger, this is bigger, because if x is bigger, that means there's a lot of uncertainty and the action can be pretty far away from from the bliss point. And from that, we did a calculation of receiver's welfare overall. This is receiver's welfare we calculated, conditional on learning which interval theta lies in. But if we go back a step and calculate it when we don't even know in which interval theta lies in, at that point, this unconditional expectation that we calculated takes this value. Okay. Now, if you look at it closely, this is always bigger than b squared. Certainly for n, if n is 2 or more. Okay, if n is 2, then this is 4 minus 1, 3, so that cancels out with the 3. So the second term is b squared, and the first term is something positive. And if you increase the value of n, it will go up further. N is what? N is the number of intervals in the equilibrium, the most informative equilibrium. So at the end of this calculation, we see that that the receiver's disutility is more than b squared. If the receiver delegated the decision to the sender, then his disutility would be b squared. Yes, because no matter what theta is, the sender will always choose an action which is higher by b compared to what the receiver wants. And so we're comparing this expression with b squared. And as long as the cheap talk game has a non-babbling equilibrium, this expression, this disutility is always bigger. And that tells us that delegation is better, certainly when b is less than 1/4. Remember what less than 1/4 means? It means that there is a non-babbling equilibrium. There's at least an equilibrium with 2 intervals in the partition. So if you restrict attention to that range, then delegating will certainly be better. In fact, even if b is a little higher than 1/4, even then delegation may be better. See, suppose b is greater than 1/4, right? So then in the cheap talk game, essentially, there's only a babbling equilibrium. Okay. And if there's a babbling equilibrium, that means that the receiver, the decision maker, only makes a completely uninformed decision. Okay. Which means that his action choice will be half the midpoint of the entire interval 0 to 1. And what will be the disutility of the receiver in that case? Remember the formula we derived? 1/12 x squared. So when there's a babbling equilibrium, he learns nothing, the receiver, then x, the value of x is 1. Okay, it's the entire interval. That's the only thing that you know. And so the disutility is 1/12. Okay, so babbling and uninformed decision making produces a disutility of 1/12. And if there's delegation, that produces a disutility of b squared. So as long as b squared is less than 1/√12, even if the cheap talk game produces no information, is better off delegating. If the bias factor is really very large, if it's greater than 1 over square root of 12, then, then delegation ceases to be opted. Then the receiver might just as well not delegate, not try to, engage in speech, because that will lead to babbling. He just uninformed, takes an uninformed decision and chooses action equal to half. There's this paper by Delegation, which I will not, discuss at full length. These are some of the things that we learned from that paper. What Delegation tries to do in the paper, here we are taking very specific functional forms, uniform, quadratic. He tries to generalize this result a little further, and he considers a more general class of preferences, which are called distance-based preferences. So the utility of the receiver depends on the absolute gap between his bliss point and the action that is chosen. His bliss point is always going to be theta, right? And the action that is chosen. So this gap is what is relevant. It doesn't matter if this gap is on the right side, if it's positive, whether it's negative, where the bliss point is. It's this gap which matters. So for that class of preferences, it shows that when the bias goes to 0, delegation is always going to be superior. Okay, so at least for low conflict situations, there's a case for delegation for a reasonably large class of preferences. Okay, the general takeaway is to understand firmly this trade-off. Okay, delegation, from the point of view of whoever is making the delegation, involves this trade-off that decisions will be more distorted, but more informed. Yes, and this is relevant to many of the kind of policy discussions that we have. For example, there's a lot of talk about local governance. We have in India, we have moved towards, or tried to move away towards more local government, Panchayati Raj, and so on. That's the trade-off. Okay. One criticism of local governance that people often make is that there may be vested interests at the local level, strong dominant castes or certain groups, landowners, what have you. They may capture the decision-making process and allocate the funds given to the panchayat in a distorted manner compared to an impartial view which the central government might have. They may favor certain groups, etc., etc. So yes, that's the downside, but the upside is that there's more information available at the local level. So when the panchayat is making some allocation decision, whether to allocate some funds to building roads instead of sinking tube wells, let's say, okay, they base it on local needs, their intimate knowledge of local needs, whether the roads are in worse shape compared to water supply. And that's the plus side, okay? And in this aspect of delegation, that it can tap into local information, is, I think, underappreciated. So what these models show is that this in many kinds of interactions, this can be the dominant aspect. Any questions? Let me briefly talk about another thing that Delegation talks about in his paper. This is what he calls intermediation. So the sender and the receiver have this bias, this distance B, right? Their bliss points are always the gap between the bliss points is always B. Now, you can think of the receiver giving up his power, but not to the sender, but some third party. Right? He can give it up to some third party who also has a bias relative to him, also maybe wants to choose higher actions, but less of a bias. Okay. And then that third party, this is the intermediary, after having granted the decision-making powers, can play the cheap talk game with the original sender because he's the one who's informed. And so let me just quickly draw a picture to make absolutely clear what I'm talking about. So this is the line. It can be either action or state of the world. We are measuring both here. So if you fix some theta, okay, the receiver ideally wants to choose this, and the sender has a bliss point, which is theta plus B, and this is the gap. Now, suppose the receiver brings in a third party, a third player, and the third player's bias is B prime, and it's somewhere between 0 and B. Then the third player's optimal action will be, this is the intermediary, he would ideally have to choose theta plus B prime, his bias, okay? So there is this amount of conflict of interest between the receiver and the intermediary. And there's this amount of conflict of interest between the intermediary and the sender, who's really the informed party. Yes, even the intermediary has no information. So when the receiver makes this sort of chooses an intermediary like this, the receiver is worried about the blue part, that even the intermediary is biased. But the receiver feels a little better about the red part, right? Because if the receiver were to play the cheap talk game with the sender, they'd have a huge conflict of interest. That's the blue, that's the green part, right? So he has reduced the conflict of interest. And as we have seen in our analysis of equilibrium of this model, the lower conflict of interest, the red part instead of the green part, gives rise to more informative talk between the intermediary and the sender, right? So the decision is going to be more informed in the various senses that we have talked about. But the intermediary will also create some distortion, right? He'll always, after learning whatever he has learned, he'll choose a higher action than what the receiver would have chosen, okay? It's just that the intermediary learns more from the sender because their mutual conflict of interest is relatively smaller, okay? So one thing that the receiver can try to do is try to strike a balance between distortion and information by settling somewhere in the middle through an intermediary like this, right? Choose somewhere somebody in the middle. If the optimal intermediary is a corner solution, meaning, the optimal intermediary is just this value, the optimal choice of B prime. If it happens to be B, then essentially the receiver might just as well delegate the decision to the sender. But if the optimal intermediary happens to be somewhere strictly in the middle, then you genuinely need a third party to carry out this scheme. And what Descent shows in his paper, and I won't walk through all the details, I just want to highlight this point, which is that, there's a range of values of B. This is the B of the original sender, the bias. For this range of values, genuine intermediation is actually optimal. It produces even better results than delegation, than full delegation. This is when the optimal choice of B prime is strictly less than B. But for low enough values of the bias factor, delegation is optimal. That is, optimal choice of B prime is equal to B. So instead of looking for a third party whose preferences are somewhere in the middle, the receiver might just as well tell the sender that, well, I empower you to make the decision. Questions at this point?
Sir?
Yes.
Sir, how do we get more distorted actions in case of an intermediary?
Not more distorted action. So let's compare the case of choosing an intermediary. Okay. So let's say one option is to choose this intermediary. Another option is to go all the way and delegate to the sender. Okay. Now, what are the trade-offs when you're thinking of which of these two options to exercise? As a receiver, you're thinking of that. Instead of delegating to the sender, if you delegate the decision-making power to this intermediary who's closer to you in preference, what you do is you lower the distortion. Okay, for any information, the sender would have chosen an action which is much further from your preferred point. So will the intermediary, but to a lesser degree, because his preference is closer to you. Okay, so you've reduced the distortion. When instead of delegation, you've gone to an intermediary, you've reduced the distortion. That's a good thing. But in the process, you've made decision-making less informed. If you delegated, all the information would go into the decision, right? The action would depend on the theta in an absolutely fine-grained way. But if you give it to an intermediary, he'll play the cheap talk game with the sender, and there will be some coarsening of the information. Information will still be broken up into some intervals, yes? So in the comparison between full-fledged delegation to the sender versus handing over the power to some intermediary in the middle, again, we see that same trade-off, right? An intermediary will lead to lower distortion, but also less informed decision making.
Okay, sir. And so one more thing, are we assuming away the search cost to look for an intermediary in this case when we're calculating, say, the
Yes.
welfare?
Yes, we are kind of assuming, making a very stylized assumption that, suppose there's a whole continuum of people out there, right? And there's one individual at least of each preference type, right? So all possible values of the bias factor relative to the receiver is, there's somebody out there who has that bias, okay? And the receiver can pick among this continuum of individuals. It's a stylized assumption, of course, but it kind of brings out the trade-off involved.
Okay, sir. Thank you.
Excuse me, sir.
Yeah.
Sir, is this theta star I the same as theta? Or is there a difference?
Say that again.
Sir, is this theta star I, which is chosen by the
Oh, sorry.
Is it-
I completely mislabeled this, which has probably created a confusion. Let me just rewrite it. Hurry, what I mean to say is that, this is for a given theta, fixed theta, this is the bliss point of the intermediary. So the action which the intermediary finds optimal is I star, that is theta plus B prime. Okay.
Yes, sir. Got it.
Yeah. Glad that you're looking at things closely. Okay, now let's talk about a more general mechanism design problem. Yes. I don't know how much you have studied mechanism design in your second micro course. I presume there have been some discussion of it. Let me explain what it means in this context, at least. Now, suppose R can commit in a much more rich and complex manner. Instead of just saying that you, the sender, you can choose whatever action you please, or bring in a third party, an intermediary, and saying the third party can choose whatever action he pleases. Suppose the R makes the following kind of announcement, and somehow he has the means, the institutional whatever instruments needed to make such an announcement credibly, which is that he says, okay, you send me a message, and corresponding to each message, I will choose the following action. So he specifies this function and commits to this function. This function is a mapping from messages to actions. Okay, this is how mechanism design problems are usually formulated. They're formulated as message games. The principal or the mechanism designer does not know a certain variable which is relevant to the decision making. He tells the informed agent, send a message. You can think of the message as being some claim about what the realized value of theta is, or the unknown variable is. And corresponding to each message, this is the action I will choose. Okay. If you think of the messages as numbers possibly representing theta, true or false, right? This function is like saying, okay, if you say theta is 0.3, I'll take the action 0.35. If you say theta is 0.6, I'll take the action 0.7, blah, 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 right? For every possible claim about theta, as in the message, what action will be chosen is committed to by the receiver, this elaborate rule. So that's an example of a mechanism. Yes, any such function will be a mechanism. And we can ask the question that what function should the receiver optimally choose, knowing that the sender will be strategic, will be smart, will optimally react to this function, this mechanism. Yes. Now, there, one relevant thing is what is called the revelation principle. The revelation principle says that without loss of generality, we can restrict our attention to truth-telling mechanisms, meaning the function is such that essentially m equal to theta, right? That it is in the interest of the sender to quote the true value of theta in the message. Yes. Whatever the mechanism designer can achieve in terms of his objective function, his welfare, through a non-truth-telling mechanism, he can always mimic that through a corresponding truth-telling mechanism. This is the famous revelation principle of Roger Maas. Okay, so in these mechanism design problems, therefore, people restrict attention to truth-telling mechanisms, which is captured in this simple equation: m of theta equal to theta. The optimal message strategy of the sender is to tell the truth. Now, here we're not allowing for monetary payments. Okay, we are in many of these mechanism design problems. You have this device of money that here there's no money involved. That's kept out by assumption. So, so the mechanism has to be of this form. Now, if you think about it, we can describe the mechanism design problem somewhat differently. Okay. So take any such function, right? So the receiver has committed to some function. Look at all the actions that are in the range of that function, meaning that there is some message which will lead to a certain action. Collect together all the actions in the range of the mess of this function. Okay, so these are all permissible actions that so the sender can induce every action in this set through whatever message is necessary to that will give rise to this action. Okay, so instead of searching for this function, we might just as well search for a restricted action set. Okay, where that action set is basically all the values which are in the range of this function that we were originally talking about. Yes. Instead of talking about a function, we can pose the question differently. We can say, okay, you know, the receiver can restrict the action set and then hand over the keys to the sender. He can restrict the action set in any way he wants. What is that? How will he want to restrict the action set? What will be the optimal restricted action set? That essentially is the optimal mechanism from his perspective. Okay, so that's the most powerful thing. You know, if there's full commitment power, all kinds of commitments that we can imagine, then the question boils down to essentially saying what is the optimal restricted action set before he delegates. The kind of delegation that we discussed so far means that you delegate without restricting the action set altogether. And here we are asking that before delegation, if you can do this extra engineering, which is to restrict the action set in some ways, how would you want to do it? Yeah. So this, you know, if you think of the cheap talk game, that is like a special case of a mechanism where the equilibrium actions of the cheap talk game are the only actions which have been allowed, so to speak. And what is the difference between the cheap talk game and the kind of mechanism design problem that we're talking about? The main difference is this. In the cheap talk game, the action which is chosen is ex post optimal for the receiver. Yes, that means after learning whatever information he learns, the action that he chooses is optimal from his own preference point of view. In this mechanism design problem that we're talking about, that doesn't have to be a case. Yes. So for example, you know, just to make it clear, for example, the receiver could commit to not choosing the midpoint of every interval that he learns, that theta is in that interval, but he can choose, you know, the 2/3 point, just as a matter of illustration. And then the assumption is that that commitment will be honored. Right? So the 2/3 point of that interval is not optimal. It's the midpoint which is optimal for him, but he has created a mechanism where he's committed to choose that 2/3 point. That's built into this mechanism design analysis. So going back again to repeat, if the receiver can do this kind of very strong commitment to a mechanism, namely restricting the action set any which way he wants, and then tell the sender that, okay, you choose an action from this restricted set, then what is optimal restriction? That's the question, right? What is the objective function? The objective function is the ex ante welfare of the receiver. Right? So how would you want to restrict the action set to maximize his welfare? This question was studied in these two papers. There's a very old paper by Holmstrom. Holmstrom has pioneering papers on a lot of things in information economics. So you can see that his name comes up again and again. And the Nobel Committee realized that some years back and gave him the prize. Goldsman and Pavlov wrote a much later paper where they generalize on this. Holmstrom's paper is the uniform quadratic case. Okay, so we'll focus on that. So let me jump to the picture. I won't give a full proof, but I'll state the result and give you a partial proof. Okay. Holmstrom showed that in the model that we are studying, the uniform quadratic model, yes, with those functional forms, the way the absolutely optimal mechanism from the receiver's perspective is to put a cap on the action. All of this is assuming B is positive, right? There's a upward bias that the informed party has. The informed party always wants higher actions. Under that assumption, what the receiver will want to do is put a cap. Specifically, it will calculate the cap. It's 1 minus B. So he says, I'm delegating decision to you. You can choose any action, but you cannot choose an action higher than 1 minus B. Okay? Actions above that are not allowed. But subject to that, you choose whatever you want to choose. Now, obviously, then the way the sender will choose action will depend on theta, and it will depend on theta in the way that the blue graph goes, right? So if theta is relatively low, in particular if it's less than 1 minus 2b, actually, then the bliss point of the sender actually falls below the cap. Okay, so he'll choose his bliss point. He'll choose theta plus b. But if theta is high enough, specifically if it's higher than 1 minus 2b, then the cap becomes binding, right? And then the action chosen will basically hit the upper bound that has been placed. And so the correspondence between the action and the state of the world becomes flat after that point. So why is this true? As I said, I'll give a partial proof. What I'll prove is that assume that the receiver can delegate, but put a cap on his choice. Assume all mechanisms of that form. And we can show that the optimal value of the cap will have to be 1 minus b. Okay, so the cap will be tighter, stricter, the more the conflict of interest between the two parties. Yes. So how do we show that? Well, that's a pretty simple exercise. So take an arbitrary cap A bar. So the receiver can delegate, but before delegation can restrict the action chosen to be between 0 and A bar. So the question is, what is the optimal value of A bar for the receiver? So what action will the sender choose under this form of delegation? Well, he'll choose theta plus b, as I said, as long as theta is low enough, cap minus b. And otherwise, he'll choose a cap. Given these distance-based preferences, you want to be as close to your bliss point as possible. So you hit the cap there. So what is R's expected payoff? Again, I'll ignore the minus sign. So I'm calculating expected disutility. Yes. For that, if theta is less than this A bar minus B, then of course the sender will choose his own bliss point, and that will be B distance away from the bliss point of the receiver. And so the receiver's disutility in that case, in this range of values of theta, is going to be B squared. However, if theta is above the point from which the cap becomes binding, then the receiver's disutility is the gap between theta, the state of the world, and the cap, because now the choice is the upper bound, the cap. So in this range, you integrate a different function. So you do this calculation and you get this, right? And now it's pretty simple. The receiver wants to choose A bar, the upper bound, in an optimal way. So it's a cubic in terms of the upper bound. You differentiate first order condition, derivative equal to 0 with respect to A bar, and that gives us the optimal value, A bar equal to 1 minus B. Okay, so once again, all of this, what does it amount to saying? It amounts to saying that the main point is really that in any organization, when the decision maker doesn't have good information, one thing to very seriously consider is to delegate to whoever has the information, even if that party has somewhat different objectives from the decision maker. Okay, and this is fine-tuning that argument. This is just saying that, well, some sort of restricted delegation is the absolute theoretical best that you can do in this kind of model structure, since the sender tends to choose higher actions than what the receiver wants. The optimal restriction takes the form of putting an upper limit on what action can be chosen. But subject to that, handing over a lot of the power is in the interest of the original decision maker. Okay. Questions? Okay, let me quickly talk about things from the other side. Suppose there's no way for the decision maker to delegate, right? Just the commitment instrument isn't there, or is not unwilling for whatever reason. Let's look at it. Let's look at commitments from the sender's side. Okay. And as we said, one sort of extreme form of commitment from the sender side could be commitment to transparency, right? Maybe the sender can pass something like an RTI Act, okay? Well before he learns theta, he can sort of write a contract or pass a law saying, I'm committed to revealing the information. I'll essentially publish the documents which contain the information. I won't just make cheap talk claims about it. I will give everybody access to hard information, whatever form that rests in, maybe the minutes or the documents. So let's push that question to its extreme, right? Suppose he can do some sort of restricted RTI Act. Suppose the sender can commit to any message strategy like this, right? That, okay, if theta takes this value, this is the message I'll send. If theta takes that value, this is the message I'll send, right? Somehow we can commit to such a function. Now, if this function is strictly increasing in abstract term, that essentially amounts to full disclosure, right? Alternatively, the function could take a step function. Let me explain it with the help of a picture, right? Suppose the sender has chosen a message function like this. What does that really mean? Okay, what that means is, in these red intervals, he has committed to reveal the exact value of theta. So if theta is in any one of these intervals, the commitment is to reveal it exactly. However, if theta is one of those other intervals, specifically these two intervals where the message function is flat, then what the sender has committed to do is essentially say, theta lies in this range, in this interval, but I'm not going to say anything further. Similarly, he might say theta lies in this range, and I'm not going to further elaborate on that. So these intervals are fully transparent intervals, according to this function, according to this picture, right? The exact value of theta in these intervals is always revealed. These are more opaque intervals. These intervals are like the intervals of the equilibrium of the Crawford-Sobel game. So if we allow the sender to commit to any arbitrary disclosure policy, right? For example, something like this, what kind of disclosure policy will be fully optimal? Yes. What kind of function will he want to create? And the answer to that, at least for the uniform quadratic case, is he doesn't want to have these opaque cases, these flat segments in the function. The sender would really want to create a strictly monotone function, mainly basically saying that he wants to reveal the exact value of theta, no matter what it is, okay, through the entire range. So full, complete transparency or honesty is the best policy, at least for these quadratic preferences. How do we know that? So the optimal disclosure policy under commitment is full disclosure, right? No caginess anywhere, no little bit of hiding information here and there. Just commit to reveal the exact value of theta for every value of theta. Why is that? Well, first, in terms of maths, you have these welfare calculations that we did, right? And there we saw that when we calculated the ex-ante payoff of the sender, we found that it was the receiver's expected payoff plus b squared, okay? And if the sender actually commits to reveal, commits to full disclosure, his payoff just becomes, his deducibility becomes b squared, because the receiver learns theta, chooses action equal to theta. That's always going to be b distant away from what the sender would have wanted. And so his deducibility is b squared. So this obviously dominates that. Okay. It has an extra term, this expected deducibility. So full disclosure dominates cheap talk, or even some partial disclosure policy. Yes. So this illustrates this dictum that honesty is the best policy. In this game, ex ante speaking, honesty is the best policy. Ex post, honesty is not the best policy. That's why a commitment mechanism is necessary, a commitment to honesty. For example, the sender could inject himself with a truth serum, somewhat tongue-in-cheek. But if he can do that, he would want to do that. Okay, now these strong results, fully disclose, committing to fully disclose information, or committing to hand over decision-making rights to the informed agent. These are optimal policies. These somewhat depend on the structure of the game, in particular, the action set and the state variable being continuous variables, right? So if theta is continuous and action choices are also continuous, that means that every time theta changes a little, it is possible to adjust the action accordingly. Yes. So fine information therefore becomes very relevant for decision making. Now, there are other games which are more discrete, lumpy. Yes. For example, the action set may be just 2 actions or 3 actions, right? And in some of those games, it is possible to have, this sort of transparency, honesty is not the optimal commitment. Optimal commitment is actually the other way around. It's committing not to say anything at all, ever, right? So here's an example. Let's look at this game. 2 possible states of the world, theta 1, theta 2. 3 possible actions, A1, A2, A3. These are the payoffs. In every cell, the first payoff is the sender's payoff. The second payoff is the receiver's payoff. Yes. Both these states are equally likely ex ante. Probabilities are half and half. Now, if they play the cheap talk game, you can find that there's a revealing equilibrium. Okay. And it's of the following kind. So basically, the sender sends a message M1 when theta is theta 1, and the message M2 when theta is theta 2. So he fully reveals in the cheap talk game itself. Why? Well, if the receiver learns that the state is theta 1, notice that he choose A1. Right? He gets a payoff of 4, which is bigger than any other pairs. And if the receiver learns it's A3, it's theta 2, then he'll choose A3. Again, he gets 4 there, the highest possible pair. Okay, so if there is fully revealing equilibrium in the cheap talk game, then actions would be A1, A3 for the 2 states. Now, how much is the sender getting in that equilibrium? He's getting 1. Why is it an equilibrium for him to reveal the state? Well, instead of message M1, if he lied and sent the message M2 when truly the state is theta 1, then he will induce a shift to action A3, right? the receiver will be misled into thinking that we are in the second state, and he'll choose A3, and then the payoff of both players drops to 0, and that's not good for the sender. At least he's getting 1 over here, right? So in this equilibrium, where he's expected to send 2 different messages for the 2 different states of the world, it is an equilibrium, right? He doesn't want to switch to the wrong message. Okay, so in this equilibrium, his payoff is 1. All right. What if he could put Scotch tape on his mouth? So technologically, no communication is possible. Okay. In that case, what will the receiver choose? What action? The receiver has no clue. He only knows that the 2 states are equally likely. Well, if he chooses action 1, then his payoff is going to be either 4 or 0. So the average of that is 2. If he chooses action 3, his payoff is either going to be 0 or 4. The average of that is 2. If he chooses action A2, the action in the middle, he's guaranteed a 3. Okay. So he'll of course choose action A2. And you can see that whenever action A2 is chosen, regardless of the state, both players' payoff is 3. So the cheap top game has a fully revealing equilibrium. It's a genuine equilibrium. And in that equilibrium, the speaker, the sender, gets payoff of 1. If he abandoned cheap top, destroyed channels of communication, or committed to silence, okay, then his payoff would increase to 3. So this game illustrates quite the opposite, right? It illustrates that in some games, some situations, the speaker may not want to commit to honesty. He may find the cheap talk game, he reveals too much in the cheap talk game, and he may want to sort of commit to not saying anything at all. Yes. But then this example is a highly discrete example. So this kind of possibility can arise, especially in these discrete examples. The feature of the continuum game, as I said, is that information is valuable even in small bits. If we learn that theta has changed even a little bit, every player would want to revise the action a little bit. And that is why the optimal commitment involves making use of as much information as possible, either through delegation or through a commitment to honesty. Okay, I'll stop there. Questions? Any questions? Are these points clear enough?